All right, so I want to do the first one together, just in case anybody missed last time and you've missed the obvious joy that is hypothesis testing. Because there's one other thing we haven't talked about yet that's on that little sheet. The sheet.
This one?
Yeah, let's see if we got any more. Somebody didn't have it. There's a p-value thing that we haven't talked about yet. We got 1. I got 1. Anybody not get that hypothesis test handout? Well, that's amazing. Anybody not get that hypothesis test handout? Oh, I kicked so much ass because I just have 1. All right, good. All right. Yay. So on the handout, I try to explain each of the 5 steps, which used to be 8 steps, which I've cut down to 5 for you. And I try to explain why we do what we do in each step, right? What it means. So you got the what the hell are you talking about? That's the hypothesis statements. You've got the what the hell can you use to talk about it? That's the can you use z-scores, t-scores, or nothing. You've got what would be good enough evidence. What's far enough away? It's part C. And then part D is, did you get far enough away? And then part E is what the hell did you just do? Right? Explain to me what it means, what you just found. So that's a little bit out of whack. 6 divided by 45 is what? Who's got that for me? Somebody do that for me. 2/15.
Oh, 0.13, continue.
Oh, yeah. So, across the states, roughly 50% of community college students are below 24 years old. In this classroom, 1 minus this, so 87% of you guys are that. I don't think we have to run a hypothesis test for that. Do you understand? What would your hypothesis be possibly? That are you a good sample to represent Grossmont College? We've had this discussion on day 1. No. But let's just assume that you are. Would that be even so 87%, that's p hat. And the claim would be it's more than 50%. Or actually the claim would be at most 50%. So we'd be testing against, we're trying to disprove that claim, that it's at most 50%. That looks really, really strong. Let's check it. Let's see. Because is this a very big sample, really? Not humongous. There's 44 of us out here, right? I included myself in there, too, 45, just to make it work. So let's try to do this claim, and then we'll talk also about the p-value, see what the hell that means. So the claim again, this is step A, is that the percentage of college students, community college students who are 24 is at least 50%. All right, most 50%, let's say. I definitely want to do an example where it doesn't follow the pattern of the examples we did the other day. The claim does not always have to be H1. We just happen to do a couple examples where it was true. On this one, which one is it? The claim, where does it go? Why in the hope? Yeah, it's got an equal sign in it, right? So that would be the null. Call it the null. So what's the H1 going to be? Okay, coolness. So there's a claim out there on a website I found that says at most half of community college students are younger than 24. We've got a sample here. We can discuss the if it's a good sample or not, but let's just pretend like it is so we can do this test. We know it's not a good sample. And it seems like, we got 87%, but it's a relatively small sample. Gallup normally takes thousands of people. So 44, maybe it's not enough evidence, even though there's a huge difference. So let's see. So it looks like it might be enough evidence to show this, but we don't know yet until we figure out a z-score. All right, to see how really far away it is. So how many tail tests will this be?
One.
One tail. So we still got to do a two-tailed test, but I don't want to start off with everything different. So it's a one-tailed test. So part B would be, what can I use? And what do I have to test? What do I have to check here? What do I have to check? Just because I only want to show that it's greater than. So where do I want my sample to show up to show evidence for this? Does it matter if it shows up either side, or is only one side going to show it? What's going to prove this is true if my sample shows up where? To show evidence that it's greater than, it can only show up here. If it shows up down there, that's no good. Right? If it shows up down there, I'm not going to do my test. There's no chance I could show this is true. So if I got 34%, no, I can't go on. There's no reason to. It looks like this is true. There's no reason to test this. So to show that this is true, there's only one tail that would do that for me, up here. And in fact, this always points in the direction of the tail, right? Okay, so the only way there could be a two-tailed test is if the claim is, we think it's different. Because how can you be different? How can your age be different from somebody else's? You could be older or younger, right? So that would be a two-tailed test. Then either way would show evidence that you're not equal to something else. Okay, so a one-tailed test is when there's a definite direction that would show me evidence for this statement.
Can there ever be an HO where it's not equal, but greater or less than?
Yeah. No.
Okay.
So the way that not equal to used to be shown was this. So if I said I thought it was not 50%, that would be that. And that kind of shows you two tails, right? Of course, now we just show freaking not equal to. So that can't be HO, because that's kind of like the exact opposite of what HO needs. HO needs an equal sign, and both of those are basically not equal. So they have got the least chance of being the HO. Right? They're directly saying, I ain't got no equal. So that there's no way they could be the HO. Okay. How are we doing so far? So again, the claim itself doesn't tell you where you're going to put it. You just write down the claim, and then you say, well, which one is it going to go in? Does it have an equal sign? It goes here. Does it not have an equal sign? It goes here. So the two claims you looked at the other day, they both happen to not have an equal sign, so they both happen to be H1. Nothing more than that. That's it. It's by definition. It's by definition. HO has to have an equal sign because H1 sets up where evidence is going to be. I can't prove it's equal to, but I can prove that it's greater than or less than or not equal to. So that's why H1 has no equal sign in it, by definition. What's step B? Second? Yeah, for this problem, I wanted to, do I use Z or T? Well, I would never use T with an NPQ problem anyway. Okay. Yeah, it would have worked with that, that's true. So, what do I want to check? Like she said, for an NPQ problem, I check to see if NP and NQ are
Normal.
greater than 5. That'll show me that it's normal. Or at least 5, I think the book says. So, N, there are 45 of us in here. And what would I use for P and Q? Yeah, you just look right back up here. Part of the whole thing behind a hypothesis test is assuming this is really true. We're going to try to show you, no, it ain't. So it's like somebody has ever said, assuming you're right. How the hell did that happen? You can't open this oven. Assuming you're right. How did I just do that? So here would be the 50. I'm going to assume that that is what P is. So 50-50. So of course, what's half of 45? 22 and a half. And so those are both bigger than 5. Check. So I use Z-scores. If one of them was not less than 5, would I use T-scores? Hell no. I would just do what?
Nothing.
I would do nothing. Right? You have the balls, you just write down, can't do it. If I were you, I'd still do it, just in case you made a mistake here. Right? Don't just stop. It's probably a bad idea. All right. So first step is, what the hell are we talking about? Second step is, what can we use to talk about it? We can use Z-scores. Then C and D are really, the third and fourth step are the most important steps. Right? What does the next step do? Yeah, sets up where the benchmark is. What do I have to go past to show evidence? And what have I not told you yet to help you figure this out? No, well, how do you find the z-score? I'm not going to tell you the z-score ever. What would you be told in this kind of problem? It's not confidence. It's actually the level of significance. And the reason it's called the level of significance, if I make it smaller and you still pass the test, that is more significant because it was a harder test to pass. So we call this the level of significance, heretofore known as LOS, not SOL, no matter how you feel about this problem. So we'll say that, and they use and it's just the good old alpha. Remember good old alpha? Alpha is the amount in the tail or tails. So alpha, let's say, is point, what you got, Jeff? 0.05, why not? So we know we're using z-scores. I know that alpha is 0.05. I know that how many tail tests is it? One tail. So can you look on your little chart, dude? Look at one tail, 0.05, and tell me what the z-score is. Yes, sir.
How do you know what alpha was?
I have to tell you.
Oh, okay.
Yeah, there's nothing I can't show. Well, obviously, the way that I drew the p, no. They got to tell you.
Okay.
Yeah. Once we learn p-value, I'll tell you why, at least in the old edition, I can't remember in this one, sometimes they won't tell you. And I'll tell you why. Because you'll get like a z-score 28. Then I don't care what the hell alpha is. That's freaking evidence. It's way the hell out there. It kills any test away. Right? So that's sometimes I won't tell you because you're going to get such an extreme value. Right? As a student, I still want to know. But it's too bad. Sometimes they might not tell you. So somebody got that? How do you look this up? Is somebody not sure how the hell to look that up?
6.679.
Ooh, let's see. Is this a Z or a T? Z is totally a Z. It could never be a T for an NPQ problem anyway. It's either normal, I use Z-scores, or it's not normal and I don't do anything. So if you're looking at your T chart, where are you going to go?
All the way down.
Of course, all of you, I stole a lot of yours. It's too bad. So if you had a T chart, you would look at 0.05, one tail, bam. So 0.05, one tail, and then I go all the way down, 1.645. Kick ass. So I know that the critical score, 1.645, it's positive because it's up there. Notice how the T-score chart has no negatives on it, right? Because you're the human, you have to know which freaking side it is. You put the negative on there if you want to. You just want to double the paper required, right? So I know it's up there because of this, greater than. So I know it's positive. Okay, now how do I say this in words, what this picture represents? What did I just shade in? What's that? Critical region or the rejection region, whichever one you would call it. Textbook calls it critical region, so that's cool. So this is the critical or rejection region. Not the friend zone. Or maybe not. So that's the area where if I get in there, I'm actually able to reject the null hypothesis, support the H1, the alternate hypothesis, right? There's evidence that this guy looks to be right if I get that far out. So how do I say that in words? If Z star good is greater than 1.645, we can do what? Reject HO, which means at the same time we support H1. Cool.
Can we say, like, if Z star is less than 1.64, we support HO?
No, you can never, ever support HO, ever. You either reject HO or you fail to reject HO. You can never show evidence that something equals something. You just fail to show that it's not equal to something. I mean, I don't know if you guys... if I can never take a sample and say, well, from the sample, it looks like it's equal to 7. I can't say that with a sample. Because I know the sample is wrong. I just know it's wrong, but it's not going to be exactly the right mean. Does that make... We know this. We know this. That doesn't mean I can't do anything with the test. That means if I thought the mean was going to be 80 and the sample comes out to be 7, and I trust my sample, that probably is pretty good evidence that I was wrong. It still doesn't say, well, actually the mean is 7. No, it's just a sample. The mean might be 11, the mean might be 20, but at least it's evidence that it's less than freaking 80. So that's why you either reject the null, support the high, or fail to reject the null. Fail to support the high. That's the only 2 things you could do. Sounds like I said 4, but I just said 2 things. All right. Okay. You guys look so happy to be here. All right.
Okay, I'm not understanding your wording then. So if Z star is greater than 1.6.5, then reject the HO, the P is less than equal, but you put support.
Definitely. If we say this guy is wrong, then the opposite dude must be right. That's all. So it's one situation. These 2 are opposite people. Whatever he says, he thinks this is the opposite. So if we say, it looks like you're wrong, dude, I could have instead said, it looks like you're right, dude. Right? It just depends on which one's the claim. So I write what looks to be 2 statements down, but they're the same damn statement from 2 different perspectives. So if he's wrong, then he's right. If I can't say he's wrong, I can't say he's right. Okay, so either I get in there and I reject and support, or I don't get in there and I fail on both counts. That's why there's only 2 situations. Yes, ma'am?
Did you reject the no, whatever, because of the 1.65?
I can't reject anything yet. I have only set up what far enough away is. We haven't even looked at her sample to see how far away we got. If I do get in here, if I am bigger than 1.645, then I am far enough away. So somebody thinks the middle is here, right? And that's basically what the HO thinks. He thinks the middle is at least that. So he thinks the middle is here. And I want to show the middle is actually further up. So I want to find a sample that's way far up. If I find a sample that's right there, then the middle could still be there. It's not very far away from that. So to show evidence that the mean is really in the wrong place, to show evidence that the picture, what I'm really trying to do is show that the picture looks more like this maybe. So I want to get into an area where it's really unlikely to be there if the mean really is there. So if I get a sample and I'm here, and it's really unlikely to be there if the mean is there, then what's more likely is the mean is somewhere else. The mean is up higher. That's why I happened to get a sample that was way the hell up there. So would it be, if I get a sample here, is it more likely that the mean is here or there? Which one is more likely? If I get a sample, randomly selected sample, and I get it right there, well, I give it some numbers. I get like 20. Is it more likely the mean is 18 or more likely the mean is 10?
18.
Exactly, I get right. That's it. So we turn this around. We go, oh, somebody thinks the mean is there. Okay, assuming you're right, look what I just did. So if your mean was there, it is so unlikely to be here that your mean can't be there. It must be higher. There's always a chance I'm wrong. That's what you got to love. You got to love that. You can't hate that about stats. You got to love it. Stats is the most honest form of mathematics there is. It says, oh shit, you just did a lot of work and there's a chance you're wrong. Welcome to life. Right? I mean, I love it. But our chances are so small. It's the most we can do in real life is to minimize the chances that we die, or that our car dies, or that we run out of food, or whatever. We can just minimize the chances. You can never make the chances go away totally. If you could do that, that would be like reaching nirvana, I guess. I don't know. I've done it. I don't see anybody floating around, light coming out of themselves. I haven't seen that yet. Saw some YouTube videos, but, CGI. All right. Sorry. Yes?
Oh, sorry. So the Z star, that's what you're trying to prove. It's not proving.
No. So, yeah, the Z star is my sample Z-score. So I take a sample. I want to see where it falls. And if no matter what my claim is, the whole test is set up to say if this looks right or if this looks wrong. Or, reject this, but I'm trying to support this. Okay, so there's a claim that it's at most this. I'm trying to show evidence that it's greater than that. If I can't show evidence that it's greater than that, then I fail to reject this. And the wording is important. I don't want to say, well, it looks like it's right. No, I just happen to fail to reject it. I don't know if this helped at all here. I mean, this is really what's behind the scenes. Somebody thinks the mean is there. I get a sample that's so damn far away from it. The z-score is so huge based on this being the mean that the mean must be something bigger. But notice, I can't say what the real mean is. I just know that the mean is bigger if that happens. That's the most statistics can tell us. Okay. So, we got a claim. It sets up where my benchmark is going to go, right? Because the high says greater than, so I know I'm going to have a one-tail test up there. We got, I'm allowed to use z-scores. Cool. I got to know that before I do the next step. So then we looked up a z-score to go along with this alpha. Right? That's beautifully set up on the t-chart. One tail, two tail. Alpha. It's awesome. I want a z-score, so I go all the way to the bottom of the t-chart, and I get this guy. So if I get a sample whose z-score is bigger than this, then I can say it looks like this guy's wrong. I can say it looks like this is right. Because again, the mean couldn't possibly be there. Then, well, in this case, what's the chances I make a mistake? There's actually too many mistakes I can make, but there's a 5% chance I make a certain type of error here, right? If that really is the middle, and this is my cutoff, how much is out here for us? 5%, right? So there's a 5% chance that this could really be the middle. But there's a much higher chance that this ain't the middle. It's actually something higher. All right. So we got this. Now that we've set up our benchmark, how far we've got to make it. We've got to make it this far away. Our sample does. The next step, of course, is how far did we make it? So what do we know from our sample? We got 6. Let me do this again. 6 out of 45 people who were greater than 24. So I want to know the percentage of people less than 24. So that means that I'm using the opposite of this, right? So 39 out of 45 were less than 24. So that's what we got from our sample. You guys were the sample, including me. So that's what we found from our sample. So what's p hat? What's the actual percentage in our sample who were younger than 24 years old? What's p hat? Don't make too big of a deal. What's the percentage of the people in here who are actually less than 24 years old?
86?
How'd you get that? Be more specific.
39 divided by
Yeah, there's 39 divided by 45.
87.
0.8.
666.
6.7. Okay, cool. So always take P and Q hat out to at least 3 places, just like standard deviation. Okay. Cool. You might realize that you don't even have to know Q hat. Because we're assuming that this is the real percentage. So when I go to make a z-score, I'm going to use this number for the standard deviation. So what's the formula? Who remembers the formula for z star in this case? It's always my data. Who? No. I don't have means. Yeah. P hat minus P. So how far away is our sample from this number? That makes sense. That's the whole point of this. Is did I get far enough away from this? And what's the standard deviation for this situation? It's the same one from the confidence interval formula. Just no hats. PQ over N. Yeah, cool. So we're borrowing that from the work we did earlier. That must be the standard deviation for this situation. So we're going to use it here also to make a z-score. So what do we put in there? We got 0.867 minus 0.5 divided by square root Good. 0.5 times 0.5 divided by n, which was 46. Why I put 40? Yeah, it's 45. Sorry, it was 6 out of 40. So now you just got to be careful about how you put it in your calculator. Parentheses are on the top. Parentheses, don't close it till you're done putting that whole thing in.
Yeah, I got 4.924.
Yeah, 4.92 something. Yeah. So our initial guess was right. I mean, 87 is freaking a lot bigger than 50. I just wasn't sure with such a small sample size if it was enough evidence. And that's really what this thing does. It says it's nice that your sample is different, but is it different enough? Does it meet this strict requirement here? And of course, did we? Yeah. Hell yeah, we blew the damn thing out of the water, right? We're way the hell up here. So if you think the middle is here, and then we're like, look what we just did. Now, of course, for this specific thing, we would never make it to a journal or anything because the first person would say, you just talked to people in your classroom? What the hell? Go away. And I can't blame them. But let's pretend like you guys are truly randomly selected, a group of people. Then that is really damn good evidence that it's not correct, that actually it's higher, right? So here's what let me see if I can throw one more thing on top of this. I knew that z-score is probably going to come out big, so this kind of sucks. But the p-value, remind me, where's alpha on this picture? Where is alpha on this picture? What is alpha? What the hell is alpha? Besides a fish dude going that way. There he's swimming that way. He's like, I don't want anything to do with the damn problem. What the hell is it? Why did I put that where it was? Why did I shade that in? What is alpha? 5%. So where is it visually?
The upper 5%.
Yeah, that is the area, right? 5% is in that little area. You with me? So 5% correlates to that z-score. Is that cool? Because we looked the damn thing up to get the z-score, right? That's the area that's in that tail. And the t-score chart is cool. It just says, just tell me the area in the tail. You don't have to do all the left and right bullshit, right? Like you have to do with a z-score chart. Bam! It just gives you the damn z-score. You got to know if it's negative or positive. Now, we just got our own z-score. All right, so here's the 1.645, and here we are, sitting way the hell out there. So the alpha is the area of the tail that the critical z-score makes. Look how slow I'm talking. This must be a note. The alpha is the area in the tail that the critical z-score makes. The p-value is the area in the tail that our z-score makes. That's it.
Can you say that one more time?
Yeah, please.
Sure, yeah. See if I can write it down somewhere. Oh, that's good. You're facing the wrong way already. Good job. So alpha is the area in the tail the critical z-score makes. In this case, 1.645. So the z-score from step 3. I don't know how you want to say that. This z-score that comes from this step. That's what alpha is. The p-value is the area in the tail that z star makes. So this is interesting. when I first learned statistics, I still don't care anything about business. So I didn't give a shit. I didn't realize why the hell they got to go one more step. I can already tell the answer to this damn question, right? What's the answer to this? Do we reject HO?
Yeah.
Hell yeah, look how far out we made. We rejected the hell out of it, right? There's no way. So, but now I realize, and in fact, in more generally, in most journal articles you look at, let me show you a couple things. Real quick, what would the p-value be here? Who's got an answer for me? What would be in the area of this guy's tail? Well, how much is in here?
About 0.
About 0%. Now, it can be a lot more specific, and I'll show you how to do something neat on the calculator. Let's do that first. Let's figure out, using technology, what the real area is up here. I'll finally show you how to do this. All right, you ready? It doesn't matter if you're ready. You're going to do it. Here. Hit second bars to get into distributions. I think I've shown you this once already. Go to normal CDF. And I want to know what's in the area from 4.92 forever up, right? So I want to go from, so normal CDF, you just put in the lower bound. And then if you want to go to infinity, you can't tell the calculator to infinity. You just tell it go really high, Mr. Calculator. Put a bunch of 9s in there. That's our stand-in for infinity. So there. What is that? So the actual p-value for our test that we've done, the actual p-value, can somebody tell me what that means?
0, 0, 0, 0.
How many zeros?
7.
No. 6. And then you got one more to get around the 4, right? So it would be 0.000043. Sure. That's plenty. So if I'm reading a journal article, let me show you a journal article. Maybe not that one yet. No, that's the other one, Jeff. Here we go. Oh, okay, sure. All right. Long-term effects of marijuana. So let me see if they got what I want here. Shoot. Thought I found what I did. Oh, here we go. No, this is not what I want to picture. Okay, so if I do p greater than 0.001. There we go. Oh, I love it. What in the world is that? Sure, why not? Prognostic impact of splenomegaly. Oh yeah, on survival of Chinese with primary. Alright, that's nifty. Now look. Obviously it's going to be, that a huge place for you to use statistics would be in stuff like examination of effects of medicine, right? You got the control group, you got the people getting the real medication, then you got the people getting a placebo, that kind of situation. So you're trying to show, is there evidence that your medicine works? So it sounds exactly like something this would be set up for. Your no would be, there ain't no difference. The difference equals 0. And then your hypothesis would be greater than less than 0, whichever one means good stuff, right? Because you want your medicine to do good things. So the p-value, now look through this thing. Look at all the p-values. Look at them all. For all these different situations, they get a little p-value. P less than 0.001. That means for that test, when they tested the hemoglobin concentrations, when they did that, did they find evidence or not to say that the null was wrong? Did they do it? If p is really small, my tail is going to be really, really tiny, right? So where am I going to be inside the rejection region? If p is really tiny, that means I'm way out there. So when I see a really small p, when I'm reading through a journal, that's all they got to tell me. That's the quick summary of what they did. I can make up my own mind. There's never going to be an alpha in the real world. You make up your own alpha. What's your own level? So somebody somewhere, that might not be good enough evidence. Hey, my alpha level is 0.00001. Whatever, dude. So that's why they just report the p-value, because then you can make up your own mind. So here they got, those are good evidence. Over here we got 0.003. There's 0.024. Oh shit. 0.024, would that have passed this test? Yes. But would it have passed if I made alpha 0.01? No. So it depends on what your own personal alpha is. Right? It's very lame Song, your own personal alpha. Okay, maybe. If you look up any, trust me, if you look up any journal article, what are you guys interested in? Tell me an interest you have. Tell me. Don't be scared. Anything. Tell me.
Midwifery?
Midwifery. Kick ass. Let's see. Let's see if anything comes up here. Let's see. Let's see if they have a study. Come on. British Journal of Midwifery. Kicks ass. Oh, yeah, there's a whole journal of midwifery. If I look at any of these guys, let me see. You can look at what the... Oh, do I have to sign up for something? Shit. Of course.
You was expecting other.
Right. There's one journal that's got stuff about that. So there'd be at least one study somewhere I can access. Oh, well.
Benefits of midwifery. How about you do that?
Let's try it. Nothing against midwifery, but maybe something else. Like effects of music. And sometimes you'll get an article that is written by somebody who has no idea what they're talking about. They just lifted it out of another place. So you try to find the link to the actual... here we go. Yes. Oh, this is still not the... Give me the study. So hard to find the actual data sometimes. Okay. The paradox of music evokes sadness. Now look at that. I kick ass. There's N equals. That's a good sign. There's no B. See, I want to get the results. There we go. There we go. Kick ass. All right. So I mean, any damn thing you can think of, as long as you can actually find an article. Sometimes these articles are hidden behind pay sites or something. But very often the articles, even if they're there, you can find them somewhere else. Somebody just posted them. Or go to the person's homepage at the university where they work, and you can find results from what they've done. But notice again, I've got my, I just saw it here, the P. Bartlett's test of sphericity, of course. Right? That would be in chapter 48, actually. Showed that correlation between items was sufficiently large for PCA, blah, 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 blah. There's even eigenvalues. Anyway, but the most important thing I want you to realize, even though you don't know what the hell some of this stuff is, I see the p-value, and that's the way they communicate very quickly to other people. This had significance. Well, our findings were significant. It was less than 0.001. And I don't know if you remember, but in chapter 1, what were they always talking about? 1 in 1,000 chance, right? Less than a 1 in 1,000 chance, and that is 1 in 1,000 chance, right? So now we're finally closing that loop about where that number came from. This is a very often cited cutoff to say, I don't care what your alpha is, that's damn good evidence. Maybe. So whatever the study was that they did, putting that there says they found evidence. Or you can say, you can have a whole list of things you studied and said, there was no evidence here, there was no evidence here, but there was evidence here. Oh, cool, now let's break that out and study that deeper and see why those are related for some reason. You know, taking the medicine with orange juice for some reason had a higher effect. The P was less than 0.001 there. Cool, let's figure out what the hell is in the orange juice that helps that happen, right? In fact, normally orange juice is the opposite with medication. I don't know if you know that.
Yeah.
Yeah. But there's some medication maybe it helps. Who knows? All right. Whew. But I want to show you this too. It's just kind of funny. This is actually not statistics. It's a purely mathematical thing. Stop doing that. I love it. The Hipster effect. One anti-conformists all look the same. Well, I'm not going to talk about it a lot because I was hoping there were some stats in there, but it turns out to be. I'm going to talk about this with my Cal 2 people actually probably. All this nifty. Look at all that nifty math in there. That's yummy. Look at that weird stuff. So I know some of you guys have had calculus, at least.
Yep.
So you know what that symbol there means.
Integral, or integrate, right?
I love it. But then very quickly, there's hyperbolic tangent. Maybe some of you guys know that. And then it just kind of goes, hello. Then you get to the really, really cool shit. Right? Anyway, I love that it just sounds like somebody was making a parody of a study, and this is actually a true study about mathematically why when you try to not conform, you end up looking like other people trying to do the same thing. So then you can just work with that paradox. Okay, let's come back here. Let's do one more together, I think, and then I'm going to let you guys try one on your own, and then we'll call it a day. Because I want to do one that's got a two-tail process to it, and I want to talk about what the p-value does in that situation. The reason I try to find those things, and I try to find it live, I try to find it in front of your face, and I did finally find something, is because that tells you could go just look, study, type in what you want, set it to be the past month or something. Otherwise you end up getting these definitions in the Wikipedia stuff. No, you want a journal article where they studied something. And actually, you can start to understand what the hell the thing is saying. Sometimes they'll have confidence interval results in there, like Gallup does. They'll always have the P stuff in there, because that's the quickest way to communicate what your findings said, right? And how much you can trust them. Okay, so let's do this. Let's try one with, let's see. With means. So test the claim. That the average community college student transfers at 4 years. So exactly 4 years, then they transfer. Right? Which means my claim is going to be what? The claim is going to be the average number of years it takes to transfer is equal to 4. Right? So the claim is going to be mu equal 4. So when I say test the claim that somebody thinks something is something, we're trying to show that it isn't, right? Now, be careful. It doesn't mean that we don't believe it is, but when you think something's true, the first thing you do is try to attack it. You get a friend to attack it. I think this is true. What do you think? No. Try to poke holes in it, right? So you could totally believe this, but the best way to have other people believe you is to try to poke your own damn holes in it. Can I show that it's false? If I can't, then I've trusted even more. It's not just my own personal hopes, right? Let's see, test the claim that the average CC student transfers in 4 years. It is known sigma equals, what you got, Jeff? I don't know, 1.48. It's probably more than that. Let's make it 2.48. From a sample of 116 students, we find, hello Jeff, we find x bar equal to 4.43. Okay, so let's see. So I got everything we need to know. You always have to be told a little bit more with mean tests for the mean, because percentages I barely have to be told anything. They really just have to how many people I talked to, and how many of them said whatever. Right, that's almost all they have to tell me. So the claim is this. Then which one is that? HO or H1? HO. It's definitely HO. It's the most obvious equal situation I could be in. It's a freaking equals, right? So what's H1 going to be? Does not equal. So how many tailed tests will we be doing? 2 tailed tests. Because to show that it doesn't equal, I just got to show either direction, right? So this is where I always, even after I've said this many, many times, I still have a student that comes up and says, well, it is not 4. Can I just stop? and what would be your answer if they ask you that? If They're sitting next to you and they're like, why can't we just stop? It's 4.43. It's not 4. Why can't you just stop? Please, Jeff, tell me I can stop. Why can't you? It's from a sample. Right? So, of course, it's not going to be, even if the real mean was 4. Any sample I take from the population, I'll put money on it not being 4. So the whole point is this different enough? That's the real key of hypothesis test. Is that different enough? And that's step 3. What's going to be different enough? Now we'll have 2 sides to it, right? How far does my sample have to get either way to be enough evidence? Because it's just a poor little sample. It's got to go way beyond. It's got to be way far off, right? Maybe. So this is going to be a 2-tailed test. So what's step 2 again? Yeah, Z or T or nothing. So what's the key here? 2 things you got to tell me on this one for a mean. One thing is, why can we do anything at all? I didn't say it was normal. Ah, yeah. So N is 116, which is more than 30. It's normal enough. Call it NE. North by northeast. It's the sequel. And then, what else do I have to say now? Then it tells me I can do something.
The standard deviation.
I know the standard deviation of the population, right? I gave you the symbol even. That's really nice of me. I'm trying to tell you I'm not going to be that nice on the test. But it didn't come from the sample. That's the key. It's just the population. It's it's everybody. So therefore I can use Z-scores, because T-scores were invented to cover my ass when I don't know this. When I do know this, I just use good old Z-scores, right? Just remember that T-scores were invented for when I don't know this, I only know S. So if you have trouble figuring out when to use it, well, if you know why it was made, it tells you when to use it. So sigma known, check Z-scores. Kick in ZS. Okay. Step 3. Define rejection region using alpha equal to 0.10. So how many tail tests was this again? 2 tail. So I know it's 2 tail. I know I'm using Z-scores. I know alpha is 0.10. What's the Z-score going to be, the critical?
1.64.
Beautiful, 1.645. And where do I put that?
On the right hand left.
Beautiful. So up here I'm going to put 1.645. Down here I'm going to put negative 1.645. Kick ass. Because again, the whole idea of this one is, I'm just trying to show it's not equal to. So I don't care which way my sample ends up. If it's far away in either direction, it works. If I'm trying to show I think it's increased, that's a 1-tail test. I think it's gone down, that's a 1-tail test. I think it's different, that's a 2-tail test. Right? Doesn't matter which way you go now. All right, and how do I say this in words now? If Z star, if it's either less than negative 1.645 or greater than 1.645, it'll do what? Reject the null, support the high. And just now remembering that we actually never wrote the freaking conclusion on the problem we just did. It's my fault. You guys are all like, I just won't do it and say, he didn't do it. No, you better do it. All right, so now I've established what far enough away is. It only makes sense then, the next step would be how far away did we get? We did get above 4, but are we above 4 enough? So what's my sample information? What do I know from the sample? I know, well, actually, I know sigma is 2.48. That kicks ass. So we're going to use that. If that's true for the population, it's obviously true for my sample that came from the population. That's why I'm allowed to use it. X bar was 4.43. What's sigma? What's the new standard deviation? The one that's true for groups of size 116. How do you get that?
Standard deviation over square root of
Yes, 4.4. No, got it. 2.48 divided by square root of 116. Right? You can't get the z-score unless you're using the correct standard deviation. Since I took a sample and I'm talking about means, I have to use the standard deviation that works for samples of size 116. So on this step, you're always going to do that. Always. So what is 2.48 divided by square root of 116?
0.230. 2.230.
Point? 230? Okay. All right. It was verified by a few of you guys. All right. So now we can make our z-score. So basically in this fourth step, you're pretty much, if you're talking about means, you're definitely always going to change that standard deviation. Now some of you guys, in the book I think writes this z-score formula now like this. They even put it inside, right? If you like that better, the reason I don't like doing that for us is because that requires another level of parenthesis carefulness, right? So I kind of like to do it on its own, but then when I do that, people start doing it twice. You take this poor dude and cut him by square root of 116 again, and that's where you start getting z-scores like 850, and you go, damn. So what I do is it's always my score minus the middle divided by the standard deviation for this situation. The z-score formula never changes, ever. It's the same for p-hat and all that stuff. It's exactly the same. So what will z-star be? So it'll be our stuff, 4.43, minus the mean, which is what? The mu. 4, we assume this is true, divided by the new standard deviation. That's pretty close here. I think you got in there. What is that?
1.87.
That's freaky. Can't take full credit for that, but that's pretty good. Part of me wanted us to fail this one, but oh well, too bad. I think we failed one the other day. I at least want to show you both perspectives of how to write the ending. But right here, I can write for myself very quickly, what did we just do? Based on what we set up here. Reject, hope, support, high. Now you got to do step 5, which is write your conclusion. So this is the when am I curious about my claim? At the very, very beginning, and then I don't care again until the very, very end. So which wording will I use? Which one is my claim? Which one of these is my claim? The HO. So then I want to use that wording. Don't let it be more than that. That's it. At the very end, how are you going to word your conclusion? You use the language that relates to which one is the claim. You always talk about the claim at the end, okay? So, let's see, where can I put this? I got very little room left. So, let's see. Did we succeed or not?
We did succeed.
Yes, we made it. So, we have found sufficient evidence, or significant, you can say either way, to reject the claim that what?
The average year.
Good, the average
Year to transfer.
number of years to transfer is 4. Now, in this particular case, we could say it looks like it might be more. So let's follow up with another study and see if it actually is more. You guys kind of with me here a little bit? A little tiny bit? So this would be good for a study like, well, the last 10 years, it's been this. What happened this year? Is it statistically different from what was happening before? Then you could do a hypothesis test, where the last 10 years would be used as the HO, as this number, and then your sample would be from this year. And you can see, is there evidence that it's taking them longer, taking them less time? And of course, considering the recession we went through, and the fact that we had much fewer courses offered than over the last few years, it's definitely gone, the number of years until transfer has gone way up, because you can't get in your freaking classes. Now you finally sort of can.
Yeah.
Kind of, sort of, almost. Yes, sir?
Did you just randomly pick those numbers? So like sigma mean, the 2.230, or did you actually?
So we did this formula, and that's where that came from, right? And the standard deviation, in one sense I did, but it's going to come from the problem. It's not something that I, as the person doing the solution, made up. It's in our problem that they tell me. Yeah. So what about the p-value? Can anybody tell me what the area is in the tail of 1.87? So here's my 1.87. There it is there. So the p-value is just the area that's in that tail. So this is old. This is section 6.2. And you're all like, I don't care, Jeff. It's still weird. But all I'm asking you is, if I'm at the 1.87 z-score, what area is above it, right? That's what a p-value is. It's just what's in the area of the tail that my z-score makes. There's one little adjustment we have to do to the number you're about to tell me, hopefully. So if you look at 1.87, what do you get? I have all of them. So if you look at 1.87, if you have your book, it's in there too. 1.87, I get 0.9693. Is that correct? Hell no, because that's below, right? So how much would be above? 1 minus 0.9693. So 0.0307. Now even that's not right. Even that's not quite right. It's a two-tailed test. So you have to double it to make it fair. So here's where we're headed. Now we all kind of know what the p-value is. So in this case, the p-value would be twice 0.0307. So the p-value here would be 0.0614. Now here's the cool thing. You ready? Here's why I just said what I said, to make it fair. What happened to poor little alpha dude? What did we immediately do with the alpha dude? Cut him in half, right? So to be honest with you, I would prefer just to cut alpha in half and compare it to that. But what we officially do is we double the area in the tail to make the real p-value. Because this is what happens. In general, oh shit, that was probably the last thing I wanted to erase. So we say if z star is greater than some critical z, blah, 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 right? With me? So that's true, and don't care about if it's further away, so either direction. So if I get out here, then I'm going to reject the nulls. That's pretty straightforward. Just tell me how far I got to get, coach, and I'll see if I get that far and I can get on your team, or however you want to look at it. If this is true, then what's true about the p-value? How does it relate to alpha? And alpha is this whole thing. So the p-value is going to be how related to alpha. Is it going to be bigger or smaller? Is the tail of my z-score bigger or smaller than the tail of the critical z-score? Smaller. So another way to test, another way to get the result is to say, not just check the z-scores, but if the p-value is less than alpha, then I reject the null, support the high. So now you really, I was saying this earlier because we know this from chapter 1, but now you see why a lower p-value means more. The lower the p-value is, the harder the test it would pass. Was this a hard test to pass? Why do you say that? Why was this not a hard test to pass? What was alpha in this test? 0.10. If I would have made alpha 0.01, there's no damn way this would have passed. In fact, I know exactly how strong of a test I would have passed because we calculated the p-value. If the test would have been 0.06, I would not have passed. Do you guys see that? If the alpha would have been 0.06, I really want you guys to get this. Right now, the alpha was 0.10. What was my p-value? 0.0614. That is definitely less than this. That corresponds to my thing being further out because then I got a smaller freaking tail than this guy does. In this case, it's 2 tails, but don't care, you just double it to make it fair. That's why it makes it fair. It makes it fair to compare. Poor little alpha dude got cut in half. So if you want to compare to alpha, you better double your freaking p-value to make it backwards fair. Right? I don't know if you guys agree. So, again, if your p-value comes out less than alpha, then you can reject the null. It's exactly the same as saying your z star was far out. Because that means that your tail would be small, right? The further out you go, the less stuff you got outside. Those go exactly together. But the more important thing about the p-value is, I know exactly how strong of a test I would pass. So if somebody made this 0.05, I'm screwed. With this sample, I wouldn't have passed the 0.05 test. I don't have that significant amount of evidence here. I wouldn't pass that level of significance. So that's why you always see just p-values reported in journal findings, at least the overview. You can get into the data, but the real quick thing they tell you is just p less than this, p less than this, p greater than this to say, we didn't find shit there. But p less than something's like, oh, they found something there. What's that? It's a very quick way to kind of pick out what you want to pay attention to in the whole damn report, right? Turn around a little bit. Okay. All right, so as promised, let me let you guys try one out on your own. There's still plenty of time.
I do too, but I'm not
I spoiled you guys too much. Should be a hard ass and should have kept this over for 5 minutes and then for the first part of the semester. Let's claim that the mean is
What's our unit? 7 what?
7 grams.
Thank you.
All right. So much like your attention span is waning, I think my creativity is waning. So you had to push me to get even units up there, but there they are. It's grams. Whatever the hell you want to put in there. If you watch too many cop shows and certain things come in your head when you hear grams. So the average amount of cocaine that was found on people that were randomly stopped by a certain officer.
Would this be a T-tail test? Because we want to see if it's higher or lower than 7?
Yeah, it's different. So that keyword means you want to show it's different, right? Like you're saying. So this is definitely going to be a how many tails?
2.
Well, different would mean not equal to, right?
Yeah.
So your claim is
Equal.
no. What's the test? The claim
Oh, the claim.
that the mean is not equal to, right? It's different.
Because it's
But you can't put a not equals in there. Oh, yeah, never mind.
The claim. You just write the claim and then you put it where it's supposed to go.
What we just did, the claim is
So the claim is
no. Our claim is not equal.
not equal.
Our claim is
But
that it's
our
different.
claim test is equal.
It's not equal 7 grams.
Our claim is it's not equal to,
Yeah.
and that's got to go where?
In the high?
In the high.
Good, which means the hoe is going to be.
Equal.
The only place it's going to make a difference is at the very end when I write my conclusion, because my claim is now going to be the high. I'm going to have to write it in terms of that at the end. It's too late. Damn it. drop already. It's too late to drop the class. So you're with me.
Not this class.
Not this.
Oh, well, every class, unless it's an 8-week class. It's an 8-week class. November 7th is the last day to drop anything.
Can't you do petition and drop it?
Oh yeah, you can do all kinds of weird shit on the sides. Sure.
That's fucked up.
Should be able to try something out. I see a lot of people just sitting there waiting. I guess might as well just leave.
Wait, I guess it's normal enough. We can use these
Yes,
Yeah.
because cities not.
because it, oh yes, I it's right there.
Even.
See, oh wait, this is 2 tail tests.
I have a question. Can you show us any drops in the class next year?
Of course it can.
I don't know if somebody dropped.
So remember, your question was, can I tell?
Yeah, no.
And that doesn't mean I'm going to
I
tell
can tell
anybody
this
else.
picture.
That's there. Yeah, there we go. So what the hell do you even need me for?
We don't.
Yeah.
What's our alpha?
Yeah, what is our alpha?
Let's make it. So I have to tell you here. 0.01.
01?
Yep.
Okay.
All right, just make sure you guys that are doing this, and maybe to get some of you actually to try this out. What's our claim again? In mathish?
Does mu does not equal
Yeah, it's
7.
different. So mu does not equal 7. That's my claim. Right? Because that's the claim that it's different. So the claim is it's not 7. So where does that go? The high, because there's not an equal sign in it. There's a not equal sign in it. It's the most not equal sign there could be. So HO, of course, automatically has to be equal. So how many tail tests is this? 2 tail. I can just leave that up there. What 2 things do you have to tell me for the mean kind of problem for step 2?
Is it normal enough?
Is it normal enough? And how do we know it is?
It's greater than 5.
Yeah, and it's, well, no.
No.
No 5.
30.
30.
I mean,
Yeah.
yeah.
So
Number.
A, N is 68 greater than 30. Normal enough. Check. B, sigma known. So I can use z-scores. I'm kind of staying away from t-scores for a moment because their p-values get a little weird. Steps don't change though, so it's all good. Still practice. Use 0.01. So for those of you just sitting there, could you at least look at your t-score chart?
How do you find?
Still on
Go to T-score chart.
the T-score chart?
What's the matter?
It says 2 tail test.
Oh, that's right.
0.01.
So if you got somebody near you with a book, it's in the book, right? I got some extras here. There's an insert in the book.
576. Sorry.
Yeah, so
Thank you.
the critical z-score. So it's a 2-tail test. 2-tail. 0.01 is going to be way back here.
Where'd you get 0.01 from? Oh, you put it, oh.
So 0.01 is way back there. If you go all the way down, you get a z-score, 2.576. So what's the picture going to look like? Good, negative 2.576 and positive 2.576. So the bigger alpha gets, the more significant it is. If you pass, that's why it's called level of significance. That's how you say it in words. Just if Z star is in one of those two areas, you reject the null. It's just so damn far away from what the null thinks that the null must be wrong.
Isn't HIR clear?
Doesn't matter. Yeah, I really want you to understand. The only time I care about my claim is just to write it down to get me started, and then I don't care anymore. I just put that phrase where it goes, and I just go. This guy always sets up the rejection regions. Period. I don't care which one my claim is. This is the guy that actually I can actually show evidence for. Yeah. I can't show evidence that something equals something. I can show evidence that it doesn't equal something. So let's see, I told you sigma was 1.98, X bar was 5. So what's the new standard deviation? How do I get that?
1.98 over square root of 16.
Yeah, 1.98 divided by square root of the sample size. Right, so I always need to do that. I don't care if you have S or sigma. Those are for individuals. I have to change it to be the one for groups of size, whatever. So don't think divided by square root makes it an S or something silly. That's not true. It makes it from individual to groups. Standard deviation. So 0.23,
401.
2401.
0.24.
Yeah, so 0.24 is good, yeah. I like it.
Oh, no,
Hmm? Then how do you always make the z-score? Yeah, it's going to be our data. So our data was, where'd it go? 5 minus 7.
Wait, oh.
Our data minus what the middle is. And we're always assuming that this is true. That's part of the whole hypothesis. Assuming you're right. Look what we just did. That's what we're trying to get to, right? Look what I can do. So over 0.240. Oh, Mad TV.
Yeah, probably don't.
Yeah, this is going to be crazy.
Negative 8.3.
Kick ass. Negative 8.3, blah, blah, blah. I knew that was going to happen. So then what would the p-value be? It would be twice 0, which is 0. Yeah. So if you do the same thing we did earlier with the normal CDF, what do you get? E to the times e to negative what?
I got just 0.004.
Oh, something went wrong. So if you do normal CDF, now you want to know what it is from negative infinity up to, keep going, nice. Hello, slow computer. Up to, what was it? Negative 8.33. Because you want to know the tail below negative 8.33. So you want to go from negative infinity. And how do we represent infinity? Negative bunch of 9s. All right. What I call RBFN, really big freaking number. That's what we use. And so even the calculator says, dude, what do you want from me? So the p-value here is approximately 0. Yeah. So then the result, how do I have to, what did we just figure out here? Since we definitely got way the hell in there, what are we able to do?
Support.
Yeah, we reject the null, support the high, and of course our claim was the high. So I want to use this language in my conclusion. My conclusion would be we have found sufficient evidence to support the claim that, and you just come back up here, support the claim that the mean is different from 7 grams. You can always just go back to the actual question and just lift that language right off of there. Do that. Plagiarize it to hell. I don't care. You got to come back to me with what it physically means. All right, that's plenty. I finally kept you the full time for once. You guys, you made it, some of you. Some of us leaked out.
Oh, we need to add this to my homework.
Yeah.